16, question 5, grade 11. In the diagram below, P is negative 8 is to T is a point in the Cartesian plane such that OP is equals to 17 units and reflects XOP is equals to theta. So X is negative 8 and Y is T. 5.1.1. Calculate the value of T. X squared plus Y squared is equals to R squared. Our X is negative 8 squared. Our Y is T squared. That's 17 squared. So T should be equals to 17 squared minus negative 8 squared square root. So this is minus 15. It's minus 15 because the y value in the third quadrant is negative 5.1.2. Determine the value of each of the following without the use of a calculator. A, so we have cos minus theta. We said whenever we have a negative angle, we'll just add 360. So this is 360 minus theta. That's in the fourth quadrant. In the fourth quadrant, cos is positive. Then cos is negative 8 over 17. B, 1 minus sine theta. So this is 1 minus. And then sine of theta is opposite, which is negative 15 over 17. So this is 1 plus 15 over 17. So it's 32 over 17. 5.2. If sine 17 is equals to A, without using a calculator, express the following in terms of A. We'll have and then they are telling us that sine of 17. So sine is opposite over hypotenuse, which means this is a 1 because it's A. So it must be A over 1. And then we can find the x value. X squared plus y squared is equals to r squared. And then our x, that's what we are looking for. Our y is a squared, and that's 1 squared. So x should be equals to 1 minus a squared. That's a. 5.2.1. Tan of 17. This is 1 minus a squared square root. So tan is opposite over adjacent. It's a all over 1 minus a squared. 5.2.2. Sine 107. This is sine 90 degrees plus 17. Sine plus, so it's 90 plus, it's in the second quadrant. In the second quadrant, sine is positive, but because we have used 90, sine is going to change to a cos. So cos is opposite over the hypotenuse. So the hypotenuse is 1. So that's the answer. 5.2.3. Cos squared 253 plus sine squared 557. So we'll just use that. So we'll square that. Plus sine 557. We'll square that. So let's check. 270 minus 253. So you want to set this up such that we go back to that 17 degrees. So this should be cos 270 minus 17 squared plus. If an angle is greater than 360, we subtract 360 from it. So that's 197. This is going to be sine 197. 270 minus is in the third quadrant. In the third quadrant, cos is negative. Because we have used 270, the cos is going to change to a sine. And then this is sine 180 plus 17 degrees. But sine of 17 is given as a, so this is minus a squared plus. 180 plus is in the third quadrant. Sine is negative there. Sine of 17 is a. So I have a squared plus a squared, which is equals to 2a squared. 5.3. Simplify fully without the use of a calculator. Cos minus 225 times sine 135 plus sine 330 all over tan 225. Negative angle, we add 360. 360 minus 225, that's 135. So that's cos 135 multiplied by sine. So it's 180 minus 45. And then this is going to be sine 360 minus 30. This is tan 180 plus 45 degrees. Cos 135 is the same as saying 180 minus 45. Sine 1, so 180 minus is in the second quadrant. In the second quadrant, sine is positive. 360 minus is in the fourth quadrant. Fourth quadrant, sine is negative. Tan 180 plus is in the fourth quadrant, is in the third quadrant. The third quadrant, tan is positive. 180 minus second quadrant, cos is negative. Sine of 45, it is square root 2 over 2. So that's going to be a minus half. And then tan 45 is equals to 1. Minus a half. Square root 2, that's just a 2 over 2. It's 2 over 4 minus a half. So this is minus a half. So I'm getting minus 1. 5.4. Prove the identity. I'm going to pick the right hand side. Negative 1 all over tan squared x times cos squared x minus 1. So tan is sine over cos. The cos will take care of the cos. Now I am left with minus 1 over sine squared x. So when I look at my identity on the left hand side, I don't have any sine there. So I need to change the sine to a cos. So sine squared x should be equals to 1 minus cos squared x. So that's a negative 1 all over 1 minus cos squared x. Okay, in the denominator, I have a difference of two squares because I have a plus b, and that's an a minus b. So it's like saying a squared minus b squared. So this can be a squared. So I have a difference of two squares. Negative 1. Let me just take out a negative first, because when I look like on my left hand side, the 1 in the numerator is positive. So I'm trying to make that become positive. So this is cos squared x, then that's a minus 1. So this times that is minus cos, negative and negative will give me the 1. So this negative will take care of that. Now I have a difference of two squares. So this is cos of x plus 1, cos of x minus 1, which is equals to the left hand side. 5.5. Determine the general solution. This is 2 sine x cos of x is equals to cos of x. We do not cancel like this when we are working with general solutions. So what you will do, you will transpose the cos of x. And then you'll have a 0. Then we'll factor out the cos x. 2 sine x minus 1 should be equals to 0. So cos of x should be equals to 0, or sine of x should be equals to a half. So the reference angle there, it's a 90 cos of 0. Yes, that's a 90 degrees. And then cos is positive. So cos is positive in the first and the fourth quadrant. So this is the first quadrant and that's the fourth quadrant. X should be equals to 90 degrees plus k 360, where k is an element of integers. In the fourth quadrant, it's 360 minus 90 plus k 260 degrees. So this becomes 270 degrees plus k 360. We are done. The reference angle should be equals to 30 degrees. And then sine is positive in the first and the second quadrant. So this is the first and that is going to be the second. X is equals to 30 plus k 260. X will be equals to 180 degrees minus 30 plus k 260. So this is going to be 150 degrees plus k 360.